Hello and welcome back to Equity, TechCrunch's flagship podcast about the business of startups. I'm Rebecca Balan, and this is usually when you would hear our Friday news roundup. But naturally, Disrupt has us doing things a little differently. I'm actually here now in the green room at Disrupt, which is probably why you hear some background noise. But by the time you hear this, we'll be flying home from Disrupt. For those of you who came out to SF, thank you. And for those of you who couldn't make it, check out the episode before this one to hear Kirsten, Margot, and Devin's live show. It was so much fun, and I hope you enjoyed as much as we did. Speaking of live shows and Equity's Devin Coldewey, today we're bringing you an interview Devin led on the space stage with Peter Beck, the founder and CEO of Rocket Lab. The pair dug into Beck's belief that to thrive, perhaps even survive, space companies will have to become a fully integrated one-stop shop. Let's take a listen.
Thank you for joining us, Peter. We've talked so many times over the years. It's always a pleasure. Before we really get started, though, I think for anybody who is worried about this, what's the over-under on a neutron launch this year?
This year?
This year?
No, next year.
Next year for sure? Okay,
yeah.
Just making sure. But let me ask you this, though. Let's say, assume everything goes perfectly well, first trip, up and down. What does that open up for you as a company? What do you get the green light on as soon as you make that successful trip? What do you do the next day? And you're like, all right, go on this.
Yeah, well, the purpose of Neutron is really twofold. One, it's to try and break up the kind of medium launch monopoly that it is today. And then the other kind of element is to launch our own stuff. Once you have the first launch, it's a great milestone, but actually that's the easy bit. Rocket number 20 is like 20 times harder than rocket number 1, because by the time you get to rocket number 20, it's all built off work instructions by technicians and all through a production system. Rocket number 1 is lovingly built by all the engineers.
Lovingly? But the other ones aren't?
No, they're all built lovingly, but you might take an hour to check a bolt rather than 30 seconds.
So as Kirsten mentioned in our little intro, it feels like Rocket Lab has grown into something much bigger. Obviously, it's much bigger than it used to be. What is the final form you're aiming for here? I mean, we're sort of like, I don't know if we're a quarter of the way there, 3/4 of the way there, 5%. What is the final form and how do you get there?
Yeah, it's funny because the plan was always to be an end-to-end space company. And I think a lot of people think that we built Electron and then we pivoted into building satellites and whatnot. But actually, the second ever Electron that was launched on the kick stage, there was recesses all around that kick stage for solar panels to turn that into a satellite. So the plan was always to build this end-to-end space company. And I think if you fast forward 5 to 10 years from now, that's what all large space companies will look like, or the very large ones at least. And that's born out of the fact that, look, launch is a great business, it's super lumpy, it's super hard, but what launch really is the enabler for something much, much larger. And I think everybody can see it playing out in real time. If you take our friends over at SpaceX, for example, with Starlink, if you want to put a competing platform up with Starlink, you have to be able to build your satellites at scale, which means you need fully vertically integrated component systems and the ability to build satellites at scale. But more importantly, you need to launch at scale. You need to be able to launch at a particular economic point at a particular scale to be successful. And I think space companies and service companies will really start to blur in the future.
What do you think is the closest we've gotten to a full service, full stack space company in the past?
I think it's relatively new. I mean, generally you focus on being a launch company or you focus on being a satellite company. Generally, you don't fuse the both. A rocket is a giant engineering compromise and a satellite is a giant engineering compromise. So when you have the ability to kind of blur those two, you end up with an interesting design point.
But in the past, I mean, we've had, of course, very large aerospace companies that have, done launch. They do satellites, Boeing or something like that in the 70s or 80s, or the companies that contributed in Apollo and Mercury. Did anybody ever even come close to really being soup to nuts?
Well, probably on the government side, I mean, you could argue that, Lockheed and Boeing, they all had launch vehicles at one point in time and they were building satellites at one point in time, but it's very government focused, like they're government contractors, supporting Apollo missions and GPS and a whole bunch of national security. But I think the difference now is it's commercial.
Yeah, and a company is just saying, literally, we're going to do whatever we want from start to finish. And that will be, we control every aspect of it. But not every aspect. I'm actually interested in your experience dealing with the many, many, many legacy and niche companies, the specialty rod makers and widget makers of the world that have powered the space industry quietly as component makers and what have you for decades. I'm curious about your experience with them. Are they the kind of like super specialists where you're like, wow, these guys really do make the best, fasteners? Or are some of them a little long in the tooth?
So I think the thing with the space industry is it's all at subscale. There is a tremendous number of small shops that, as you say, build exquisitely beautiful things. But if you turn up and you say, look, I need 1,000 of something, their heads just explode. And the space industry is it's scaling now at a rate that's never been scaling before. And a lot of these, small companies really, really struggle to scale. And then you have the legacy providers as well that kind of fall in the same camp. That's one of the things that we've kind of focused on. I mean, when we went to go and build our first satellite, I remember the very first thing that we went to go and order was some reaction wheels. And we rang up Doug Sinclair and said, Doug, we like your reaction wheels. Can we buy some reaction wheels? And he said, yep, sure, Pete, but I've closed my order book, so it's going to be a year until we can supply you some reaction wheels. And I haven't got a year to do anything. Like a year at Rocket Lab is like eternity. So we said, okay, Doug, that's great. Can we come up with a different kind of deal? And we ended up buying Sinclair. And, Doug's team used to build 150 reaction wheels a year, and this year alone we'll produce over 2,000 reaction wheels. So what we've kind of done is if you took a satellite and you laid it out on the stage here, we pointed to all of the bits that were subscale or they really sucked. And then systematically went after all of those bits and bought the best in class, or we created our own technologies as well, and then scaled them. So, solar was another good example where, Solero is a legacy solar cell manufacturer. They did the James Webb Telescope and all the Mars stuff. So super cool company, but just not really that scaled. So we went in there and painted all the walls black, put some Rocket Lab logos up, some snack machines in the corner, pulled down all the cubicles and said, let's go. And then now, we're the largest solar cell or space grade solar cell manufacturer in the world. So that's kind of systematically what we've been doing to try and create some scale in an industry that really suffers from scale.
It necessarily needs a bit of capital. You meet one of these legacy companies that have been around for 20 years and you say, I'm going to do this myself. But then you're like, well, that's going to cost me $30 million. How do you judge when to buy and when to build and when to sort of thread the needle?
Yeah, so, something like solar has a tremendous amount of a moat and a barrier. Like these are, semiconductors, decades and decades of government-funded research. That's not an easy thing to kind of jump in. And then on the other side of the equation, we built some spacecraft for NASA recently called Escapade, and there's one or two legacy titanium sphere manufacturers in the US. So we went to one of these legacy suppliers and asked them to build these titanium tanks because they're very thin wall, very bespoke, got crazy fluid control devices inside them. Anyway, we still haven't got those tanks, and the spacecraft are finished and ready to launch. And that was an example where these legacy suppliers just were terrible, absolutely terrible. And we ended up developing a new 3D printing process for these thin wall titanium tanks and then EB welding them together and doing all these sorts of things. That didn't cost any money at all. That cost no capital at all. But now we can build, thin wall titanium tanks in any shape and size we want. It's horses for courses. Some things have big technology moats that are super scary, and other things look scary but use different approaches. It doesn't cost any money at all.
Is there any upside to being a supplier for titanium spheres now? Now you're the leading supplier of spheres or other shapes made of titanium. You can be that guy.
You could be that guy. I mean,
Are you that guy?
I'm not sure that's the most exciting business in the world, but nevertheless, it's super critical. And then for us now, as we look at building interplanetary stuff or big balls of delta V in orbit, you can just take that whole tank section, which is the longest lead time item and quite often very expensive, and just delete it.
So let me ask you about the interplanetary spacecraft type things. When you get a contract, say, okay, we need to build a spacecraft. Maybe it's your first spacecraft. How do you start building up that team? How do you stand that team up? Who's your first hire?
Well, I mean, don't underestimate the importance of not understanding how big a bite you've taken off. Because I think if you sit down and write down everything on a piece of paper that you would have to do to achieve some of these things, then you'd never start. A good dose of kind of skepticism and arrogance is super helpful.
I'm writing this down.
Yep.
Skepticism, arrogance. Good.
Yep.
Okay.
But I mean, look, Capstone was a great example of that. For us, it was our first first deep space mission. And we had a good understanding of theoretically it was possible, but we had to develop crazy new stuff to be able to execute that. The team at Rocket Lab, there's about 2,000 or just a little bit over 2,000 of us now. So, there's a good cross-section of experiences and talent. So put a team around something and we can really get stuck in.
So let's talk a little more about the spacecraft side of things and the interplanetary missions, because these are it's so fascinating. And I know that this is a passion of yours as well. It's like you want to build something to go to any planet really will do. And you've already sent over Capstone and we got Escapade. Coming into this as like a fresh like you had not made a spacecraft before you made Capstone.
Yeah.
What were some of the lessons you learned along the ways, like coming as a with a totally fresh perspective to this, knowing like, oh, well, obviously we built them like this and this and this, and this is how you build a spacecraft. So we'll take the lessons from the last 50 years of spacecraft building, and then you get into it and you're like, oh my God, why did anybody ever do it this way?
Yeah.
What was some of the experiences you've had like that?
I don't want to upset any spacecraft people, but spacecraft are way easier to build than rockets. They really are. Now, deep space stuff is a little bit more challenging because you've got a whole bunch of radiation and nasty environment to kind of deal with. But at a higher level, they're a much more passive, simpler thing to do. You know, there was a lot of learnings. I remember sitting in a design review for Capstone, and one of the GNC team was doing all of the trajectory calculations. And that particular mission was really difficult because we're using a whole bunch of weak boundary effects to get to the moon. We did 7 orbit raises around the Earth to finally shoot off for a TLI to the moon. And each one of those orbit raises, we had to do a complete tidy up of the trajectory from the last, correct for all the errors. And so the GNC team had 24 hours to redesign a trajectory to the moon. The first trajectory that they designed to the moon took them about a month, and we had to get that down to 24 hours.
Oh.
So every 24 hours we'd iterate on this trajectory. And I remember we had to allow for the solar pressure, the photons hitting the side of the spacecraft and altering the trajectory just from the sunlight.
Really? Okay.
Because that was enough to cause this issue. And then, that's a relatively small disturbance. You think about engine shutdown transients, where the engine, you command the engine to shut down, and there's a transient as the engine shuts down, and characterizing that transient so that you don't end off way out in deep space. Because when you're at the Earth and you've got to time it with the moon, that's not trivial.
Have you found that physics-based simulators have become more useful in the last few years, gotten a little better?
Yeah, the maths hasn't changed, but I guess some of the tools around it have.
On the team thing, I forgot to ask, is there a lot of competition for talent right now? If everybody's thinking about building spacecraft, but you gotta build up that team. Is there competition?
Yeah, look, there's always been competition for talent for as long as I can remember. Our sales pitch is like, if you actually want to build shit that goes to space, come work for us. And it's amazing, the amount of companies that have cool ideas and build cool stuff in the lab but don't actually get to fly it. Always a lot of competition for talent, and the statistics for Rocket Lab aren't particularly good. It's twice as easy to get into Harvard than it is to get into Rocket Lab. So the threshold is super, super high for anybody to get in. But
you have legacy admissions? Just if I know somebody like you, I can get in?
No.
Okay. Thanks for coming out. So tell me a little more about the spacecraft that you are most personally excited about, the mission that you are most personally excited about, like the elegance of the design or how complicated the lunar injection, process is. Obviously you're proud of that, and rightly so. So what are you hyped for?
Well, actually, it's a mission that's completely unfunded, and it is a small financial drain on the company, and that is...
Small financial drain?
Very small. It's a nights and weekends project, and that's our life-finding mission to Venus. And that for me is, I'm personally very passionate about that, because I think one of the biggest questions that we can ask and answer in the universe is, are we the only life in the universe or not? So this mission is designed to specifically target the clouds of Venus. There's a very interesting sweet zone about 50 kilometers off the surface of Venus, where there's believed that, the conditions are just good enough that there could be life there. And this mission is designed to go there, and it's a completely private mission. Like I say, it's a nights and weekends kind of project. We're using the basis of the Capstone bus to get us there. And then we separate off a probe once we arrive at Venus, and that probe has around about 250 seconds of time to interface with the Venetian atmosphere. And we have a nephlometer instrument in there that's basically designed, to look for life. So it's kind of like a go, no-go instrument for life.
Right.
Green light, red light. So it's a very rudimentary, because the telemetry stream that we can get back from a little probe entering the clouds of Venus back to Earth is a pretty narrow stream. Super cool project. The probe is like a Jules Verne looking thing. It's just really neat. I certainly hope we can get that one away soon.
Yeah, that sounds interesting. I know Venus is pretty hairy. It's no picnic going to Venus. It's nasty out there.
It's nasty, yep. But I think it's a much more interesting planet, not to choose favourites or anything, but much more interesting planet than Mars. Mars politically is excellent because you can put a footprint on the surface of Mars, and that wins heaps of votes. But Venus, you're never putting a footprint on the surface of Venus, but I think Venus as a planet is a lot more interesting.
Well, since you brought up politics, I wasn't going to ask this.
Did not mean to bring up politics.
Don't worry. Well, look, seriously though,
that is another rocket.
No. It's all right. It's done. Look, I'm going to ask you. It is a bit of a sensitive topic, but your fellow spaceman Elon Musk has been acting on it in sort of a partisan way. Do you think that's good business?
He can do whatever he wants to. I'm just a guy from New Zealand trying to build a rocket. So.
Very fair answer. Do you get to go in and actually like poke around on this? Is this weekend and afternoons? When do you do this project? Do you get to go in there and poke around with the thing and say, make this bigger, make this faster?
Yeah, absolutely. I mean, probably about 30% of my time, I'd like it to be much more, but 30% of my time is with a wrench. So it's super fun to be very hands-on, but I'm still the chief engineer of the company, so probably about 50% of the time I'm deeply involved in all the main engineering decisions within the company, and 30% of the time I actually get to get my hands dirty. I think a lot of people worry when I turn up, but I still like to get my hands dirty. And then the other 50% of the time is just useless rocket CEO stuff.
Like this?
No, this is wonderful. This is a great use of time.
So one of the consequences, it seems, of building a full stack rocket company or a space company is that you're free to launch as many things as you want if you can afford it. As we've obviously seen that with Starlink, is they're offering a service and it's all very cool, but people are concerned that there's going to be a proliferation of many different constellations in various orbits, and this is going to make things more complicated. How do you see this playing out, and do you think the coming verticalization of space companies is going to contribute to that?
Yeah, it is, for sure, and it is a real concern. It's something we've been very vocal about, and everybody, all the nations of this planet need to come together at some point and come up with a set of rules, some space traffic, if you will. Now, unfortunately, as a race, we don't seem to be very good at projecting things forward and then doing something about them before they happen. So I think more likely what will happen is there'll be some kind of incident in orbit, and then we'll all get together and make a set of rules. But you're right. I mean, China has a 30,000 satellite constellation. There's a couple of 30,000 satellite constellations here in the US. Europe will have the same. Every emerging space nation will put up their own assets. So it will get busier and busier. And I can remember with Electron, we used to have a 3-hour launch window, very sedate, lazy 3-hour launch window that we could go and fly. And then some of these constellations start to get populated, and it got down to 3 minutes at one point. And then we went back to the FAA and developed some new modeling techniques, and it's opened that window back up. But it just shows that if you did nothing, then you'd be down to 3-minute launch windows.
So what would such a traffic monitoring system even look like? I mean, you've thought about this a lot. What would the basic, if you were the Lord of Space, which maybe you'll get a chance later on. If you were the Lord of Space, what would you set up? Would it be like, only 10,000, this?
It's actually really simple. I mean, it's just transparency. But there's a lot of reasons why a lot of people don't want transparency. Because at the moment, if you think about all the models, if your spacecraft is not creating any maneuvers, then it's very predictable. So it's here, and then 90 minutes, it's back around here with an orbit position and so on and so forth. So it's actually very predictable. The challenge is when, all the computer models start to break. If you actually, you were here and then you make a wee maneuver, and then in 90 minutes time, you're no longer here, you're over here. And if you're continually moving your spacecraft, it becomes mathematically impossible to predict the conjunctions. So the only way you get around it is complete transparency. So all of the governments and with all of their assets and all the commercial assets would just have to, provide all the TLEs and where they are in orbit, and the conjunctions could be computed. And you'd have to also add in, I intend to burn here to get to here, and then it's mathematically computable.
So when you're talking with defense and these people, is there any tension there with the question of like, well, if we're going to, as a country be doing our own thing, because we have our own reasons, just like any other country or sovereign nation, to not disclose for defense or intelligence purposes. Is that something that, as the actual creator of the hardware, you need to negotiate with these people, or is it just it's in the contract, or it isn't, or what?
Well, I mean, we're not operating the spacecraft. So, we'll deliver the spacecraft to the customer, and then they're responsible for the operations of it and their orbit and, the mission that they intend to carry out with that. So it's not something that we certainly have any kind of, responsibility over. But I mean, look, at the end of the day, I don't want to paint the wrong picture. I mean, space is big. And, you could take all of the spacecraft that are in orbit right now and they'd fit in like a football paddock. So, it's crazy. The challenge is that the closing speeds or the conjunction speeds are just super high.
Yeah.
And
the little visualizations we always see are kind of misleading because the dots are so gigantic.
Yeah, they're like the size of countries.
Yeah.
So, yeah.
But you will be operating more as time goes on. How do you make that operating piece work? Building something like that up from scratch, I'm sure SpaceX has something to say about it. Amazon's going to be getting into this. But you're about to have this 18. You're not going to be operating that one, but you will be operating one soon. What does it look like building up that kind of oversight mechanism?
Yeah, well, I mean, it's pretty straightforward, to be honest with you.
Is that something that hasn't changed so much in the last 50 years?
Not so much. I mean, right now, as I mentioned before, there is no kind of international rules that everybody has to log in and comply by. So there's a lot of panicked 2 o'clock in the morning calls to other people about conjunctions that still occur.
So really, we just need better phones. Call each other better.
Yes, and space traffic management, yeah.
Do you want to talk about the documentary at all?
Can do.
If you haven't seen this document, Wild Wild Space, it was a very interesting profile of you and our friend Chris Kemp. I'm just trying to...
So just be clear, I did everything I could to stay away from that documentary.
Wait, what?
Well, I mean, so every opportunity with Ashley, we tried to convince him that this was a bad idea. So,
and that's why you should definitely watch it, because it's very interesting. But was it did it make you uncomfortable having people around, or did you just disagree with the thesis of the documentary?
Yeah, I mean, look, we're just about building rockets and spacecraft. So the amount of access that we gave the team was just a few interviews and bits and pieces now and again. So there wasn't a tremendous amount of access. But to Ashley's credit, he came over to New Zealand and just stalked us for months on end and parked outside my mum's house, I think. So he was well dedicated to the...
yeah, that's a work ethic. That's great. Well, we'll talk about getting us access, better access. We'll make a better documentary. So you talked about spending a little time with a wrench in your hand. I think that's great. When I think of Rocket Lab, I've been covering you guys for a long time. I think of the very early days and seeing the pictures, you guys out in the forests, and forest was a launch stand somewhere, and really just grease monkeying the things together. Do you miss those days at all?
Yeah. I mean, whenever I get the chance, try and be back on the tools. I mean, I was lucky to spend a few weeks at Stennis with the Archimedes team just recently on getting that first hot fire over the line, and yeah, it was super fun to get back on the tools.
Was it hard, though? I mean, back in those days, was it fun? Was it hard? Was it both?
It's like type 3 fun. Super hard, and then you look back on it and you think, yeah, that was quite fun. Yeah. But I mean, nobody, I don't know. I'm not sure you get in this business to have fun. I think it's rewarding, but less fun.
Well, I've got another panel here in just a second, but I'd like to get your thoughts on this whole market that they're pursuing. They're doing a full reusable, so Stoked Space is going to be doing a full reusable thing. Inversion Space is doing targeted reentry of assets and cargo. Does that strike you? Is this a realistic future of where we're dropping cargo on target, or full reentry for small rockets and stuff like that?
Yeah, I think there's bound to be some high value things that it makes good sense to return, because they're always it's going to have to be high value because it's going to cost a lot to do. We were lucky to win the Varda contract, where we built a spacecraft that hosted Varda's capsule, and they made some high value pharmaceuticals in that capsule, and then re-entered it and landed it in the Utah desert, and that's super cool. So I think for particularly high value things, there's going to be a down mass market. How big that market is, I'm not exactly sure, but
are there any interesting new markets like that you would be curious about exploring as a full stack company when you have a little more freedom to try some interesting new things?
Yeah, we're always looking at crazy stuff. We have people whose job title is crazy shit thinking. So we're always looking at that cool stuff, and it's amazing the experiments and the bits and pieces that quietly fly in Electrons now and again.
Well, I'm glad to hear you're doing crazy shit. Oh, well, I think that's all the time we have for today. Thanks again for coming out. Always a pleasure.
Thanks, Devin. Cheers.
Equity is produced by Teresa Loconsolo with editing by Kel. Bryce Durbin is our illustrator, and we'd like to give a big thanks to our audience development team and Henry Pickavett, who manages TechCrunch audio products. Thanks so much for listening, and we'll talk to you next time.